So hello everyone, today I will be explaining to you my latest project, DevOpsifying 3-tier EDU Connect. So EDU Connect is a project I have built before 2 semesters in my college. It is a 3-tier project which includes React, Spring Boot and database. So I will be explaining to you how I have DevOpsified this 3-tier project. And also one more interesting thing here is that we'll be following multi-repo architecture. So basically I already have front-end repo and back-end repo. On top of that, I will be making infrastructure repo and GitOps repo. So infrastructure is for provisioning the infrastructure on AWS, and GitOps is to manage Kubernetes manifest file. So our repository structure is like this. We have front-end repo, back-end repo, infra repo for Terraform things, and GitOps repo for Kubernetes and ALB things. So what type of tech stacks we are using? So our core tech stack includes Docker, Kubernetes and ALB. And also for CI/CD we are using GitHub Actions. It is basically for front-end and back-end CI/CD, and we have separate repo infra repo, and for that we will be using Jenkins. So we will be using two types of CI/CD tools, and it will be very interesting to know that why we are using two tools. Also we have ArgoCD as a GitOps-CD tool. So we have GitOps repo, right? So if you want that, we have to deploy continuously. So we will be using a tool called ArgoCD, which will continuously monitor our GitOps repo, and it will deploy the whole manifest files on my EKS cluster. Then we have infrastructure. For infrastructure we are using Terraform. It is widely used and open source tool to do infrastructure as a service things. So what type of infrastructure we will have? We will be having Amazon EKS, VPC, IAM, S3 and CloudFront. And for security things, we will be using Trivy, OWASP and SonarQube for all the security things for our codes and maybe Docker files. For monitoring, we are using Prometheus and Grafana. And these are detailed things, but as of now, you are good to go with these many things. So this is high-level overview, like which type of things I will be explaining to you. So this project is gonna very interesting. It is very challenging. I have done it over the 2 months. So now let's jump to the architecture. So this is the architecture which demonstrates my project briefly. So this is developers. When developer pushes code to Git, then either it is for front-end and back-end, or either it is for infra. So if it is for front-end and back-end, we will be using GitHub Actions as a CI/CD tool. If it is infra, then we have Jenkins CD tool. So this is pipeline for front-end CI, this is pipeline for back-end CI, and this is infra CI/CD which is on Jenkins. So what I am doing in CI, front-end CI. So when our code pushes, I will build the React app. As I have told that my front-end is on React. So I will use npm. I will build the React app. Then I will do Trivy, OWASP, scans. So these are basically security tools which comes under the DevSecOps. So Trivy is used for checking the vulnerabilities of Docker image, while OWASP is used for checking vulnerabilities over the we can say SDKs or the dependencies of code. So here I have Spring Boot and other Spring Boot dependencies. So OWASP will check whether I have critical vulnerabilities on top of the Spring Boot dependencies. Then after building the React app, I will deploy it or I'll put it on the Amazon S3 bucket, and this is object storage service. So I have static files which I will store on the AWS S3. Then we have CloudFront. So some of you might not know the CloudFront. So CloudFront is a content delivery network which delivers static content worldwide with low latency, with caching. So AWS has their edge locations all over the world. So maybe in India also we have multiple edge locations. You might be confusing we have like AP Southeast, AP South 1, AP Southeast 1. So these are regions. Apart from regions, AWS edge locations, they are basically used for edge content series and edge content computing. So this is the CloudFront, which is like content delivery network, which caches the content of the AWS S3 and it will provide worldwide. Now what about Backend CI? Backend CI is like when our code pushes, first we will do Maven build. So Spring Boot, for Spring Boot I am using Maven tool to build and to compile and all things. Then again trivia and OWASP scans which were there on Frontend CI as well. Then after Docker build, I will push it to the either Docker Hub or Amazon ECR. Then whatever the image tag I will have to update it into the GitOps repo, because you know that GitOps repo is used for deploying backend things. So I have my whole backend thing in GitOps repo. So when I do backend CI, it will generate one image. That image tag I will have to update in GitOps repo as well, because at the end our ArgoCD will be watching this GitOps repo. So if GitOps repo is up to date, then ArgoCD will also update or cluster based on the repo. So yes, here it is written that watches and see. So ArgoCD watches the GitOps repo and it will sync as it is, which is there in the repo. You might be thinking that this is very, this is very exaggerated, but I am just telling you overview. After that I will be going detailed in code section. So in VS Code you can see I have all the repos. I'll be explaining to you each repo, but as of now just know the overview. So this is EKS cluster. Again I am not going to depth because this is a overview. So we'll see in the GitOps part that what all sort of things are there inside the EKS cluster. So yeah, this is for the backend part. And what about frontend? So when public user comes, it will access frontend through CloudFront, and CloudFront will use S3 as a backend for delivering the files. Then we have to use backend as well. So S3 files will point to the backend, and it is via AWS ALB. So ALB is used for distributing requests to the EKS cluster, and it will use the backend services inside EKS cluster. So this was the overview of architecture. Now first I would like to give you explanation about infra repo. So these are some repos. I'll first explain you infra repo. So I am using modular architecture. What modular architecture is, like you have namespaces available like EKS, IAM, RDS, S3 plus CDN, then VPC. So I am separating the concerns, and so we'll start with the EKS, or maybe we can start with VPC first. So VPC, why we require VPC? Because EKS cluster cannot be deployed directly on default VPC, because EKS cluster will require public subnets and private subnets. So default VPC only has public subnet, so we will have to make our own VPC with which correlates with the case requirements. So first we have private subnets. Now you know that we have 3-tier architecture. We have ALB, then we have middle level backend servers, and then we have database. So we will require the servers and database will require private subnet, while front layer, which is for using ALB will require public subnet. So I will make private subnets for two things, that backend servers and database. So this is worker private subnet 1, then we have worker private subnet 2. So worker private subnet means that backend servers. So like I have nodes, so that EKS clusters nodes will be consisting of backend servers. So that way I have written here worker private subnet 1, then worker private subnet 2. Then we have RDS private subnet 1, RDS private subnet 2, and accordingly we have route tables, we have net gateways, and we have route table associations. So I am not going into very detail because otherwise it will be very long video. So that's why I am explaining you briefly, not very briefly, but you can go and check out my code. You will be able to understand it very clearly. Then we have public subnet. So public subnet is used for ALB. For users will directly point to the public subnet as part of the backend request. So we have public subnet 1, public subnet 2. Again we have public route table and route table associations. Now one thing to note here is that public subnet will use internet gateway. So its gateway ID will be AWS Internet Gateway, and here private subnet. So private subnet will use net gateway ID because private subnet requires only outbound access, while public subnet requires both inbound and outbound requests. So that's why we have to know that private subnet is using net gateway and public subnet is using internet gateway. And then we have VPC. So we have created VPC, then we have CIDR block. I am taking default variables like this. So this is VPC CIDR, then we have all subnets CIDR. Now inside VPC I am creating internet gateway and net gateway. So these things you have to know. Also net gateway requires elastic IP because private subnets will use net gateway in route tables. So it is necessary to use elastic IP so that whenever net gateway crashes or it is restarted, the elastic IP or its public IP will remain persistent. So that's it in the VPC section. Now I will move to the EKS section. So inside EKS, if you start with EKS cluster, then EKS cluster has some VPC configs. First of all, it is having role ARN. So what is this role? So this is cluster role, and this cluster role includes multiple policies such as EKS cluster policy, EKS VPC resource controller, etc. And this role will be used by EKS cluster, or we can say EKS clusters control plane to handle other resources. Now VPC config. So VPC config, inside it we have endpoint private access as true because we want to access the EKS cluster remotely so that we can directly access it into our terminal. So that's why I have enabled the public access. We have private access true. Then subnet IDs. So we have worker subnet IDs as a clusters subnet IDs because whatever workers will be there, that all workers are nothing but nodes inside our cluster. So the subnet group of a cluster is same as subnet group of workers. Nodes cluster role we have seen. its attachment and certificate. Now TLS certificate is used for the OIDC. Now what is OIDC? We know that our EKS, our Kubernetes cluster will have to use certain AWS things like ALB or VPC or some IAM roles or other services. So for all of them, we will be using OIDC as a identity provider or identity access provider for our pods. So if I want that this pod will be having S3 access, then we must be using OIDC in order to give access to pod of whatever services we want. So it works on JWT tokens, like it will provide JWT token to our pod, and then pod will request to the AWS IAM, and it will get the credentials they require. So it is nothing but like using IAM from Kubernetes. So that way it is required. So we are making TLS certificate and its URL. We have to provide this EDU clusters issuer URL. Then we are creating OpenID Connect provider. This provider will be associated with this EKS cluster. So that's why we have to provide URL as the issuer. And thumbprint. So we have to provide fingerprint of the TLS certificate. And this was all about EKS cluster. Now if we go to node group, then inside node group we have cluster name, then node group name and subnet IDs. So worker subnet IDs is same as node group ID. Then we have scaling config, we have capacity type on demand, then also we have launch template. So we will be seeing launch template in the let me find the launch template first. So this is launch template which will be used by our nodes in order to launch the EC2 instances. And then we have security group of this worker. We have launch template. So yeah, this launch template having instant types as T3 small. Then we have block device mapping. We have IAM role for this worker node. Whatever nodes this node group will create, they will directly assume, they will defaultly assume this IAM role. What policies does it contain? So it contains EC2 worker node policy, CNI policy and container registry read-only policy. So this was about node group. Now our big picture is like we have VPC. Inside VPC we have multiple subnets, 2 for private, 2 for that worker nodes and 2 for RDS. Now inside worker node subnets we have node group. That node group will contain the launch template. Launch template will have certain configurations to launch EC2 instance. So just know from the above perspective. Now we have EKS cluster done. What about IAM? So we will require IAM for other things. Now let me explain you some things. So we have Ingress Controller. Ingress Controller is a concept inside Kubernetes. So if we want that our ingresses will get certain resources, maybe in cloud or locally, then we will be requiring Ingress Controller. So here we will be having AWS Load Balancer Ingress Controller. What it will do, whenever you will create ingress resource inside your EKS cluster, it will directly create the ALB associated with that ingress. So via that ALB you can then access publicly your whatever your resources will be there inside the EKS cluster. So for that ALB Ingress Controller we will be using IAM roles, and that is what I have defined here. So I have ALB controller. this is the policy which that ALB controller will be using. Then we have policy document, which is like what type of assume role policy our role will have. Then we have created ALB controller role. So this is ALB Ingress Controller role, assume role policy. Then policy, IAM policy we have defined here will be associated with this role, and this role later will be used inside the GitOps repo. I will show it to you. But this was about ALB Ingress Controller. And what about EKS external secrets? So this thing I have as of now commented out because I have mistaked one thing, that I was making these Helm things, Kubernetes things inside Terraform, but it is bad practice. It is not done in productions. We have to use GitOps repo for creating such things. So that's why I have commented out and I have moved it, or I have migrated it to the GitOps repo. Now this was inside the IAM. What about RDS? So RDS is a general RDS MySQL instance. It is our multi-AZ. So some settings you can see that engine is MySQL, engine version, instance type will be db.t3.macro. Then storage we have 20 GB, username, password, db name. Then it's subnet group. So subnet group we have already created for this RDS. So we will be using both the private subnets we have created for the RDS. And here is the security group, publicly accessible, so we don't want it. And multi-AZ, it is multi-AZ, so we will be having multiple instances of this RDS DB, which will be multi-AZ. So if one instance fails, another will be handling the request. Then security group. So this is the things, like from the worker security group you will be getting 3306 TCP request. So you will have to accept it. That is what this rule says. And egress role, and that's it. So this was RDS. Now we are done with EKS cluster, we are done with RDS. What about front end part? So as I have told you that front end will be deployed on S3 plus CDN. So S3 is for deploying the files, static files, which will be generated by the front end repo, and that files will be delivered by the CDN or content delivery network. So in AWS it is CloudFront, which is the service provides the CDN. So we will be making the both S3 bucket and CloudFront. First see the S3 bucket. So we have S3 bucket, its bucket name, then origin bucket policy. So we have to allow the CloudFront to access the S3 bucket. For that we'll be using the CloudFront's ARM to access this S3 bucket. So we are giving that string equals. So source ARM means from this source, AWS CloudFront distributions ARM. From this source we will be accepting the request, and that's what this origin bucket policy says. So this was about the S3 bucket policy. Also we have to block all the public access. So I am blocking all the public access from SELs or end policies. Now what about CloudFront? So here is the CloudFront. So CloudFront has origin access control, origin type as S3. So it means that we are providing the contents from S3. We have signing behaviors and protocol. The CloudFront distribution, this was origin access control, and this is CloudFront distribution. So we have origin as static S3, this is origin ID, then domain name. So we will be acquiring domain name from this S3 buckets resource, and origin access control ID. So this object will pass inside it. Aliases. Alias means what type of domains will be pointing to this CloudFront domain. So you might know the CNAME in domain name service. So that CNAME, later if you want that I have this particular domain I have purchased, and I want that from this domain you want to point to the CloudFront domain. So you have to pass that your custom domain inside the aliases, so that later you can directly flow from that domain to CloudFront domain. Then we have IPv6 enabled. So root object is index.html, because in our S3 bucket, when static files will be pushed, I want that CloudFront should provide default root object as index.html, because it is the home page of any website. Then caching behavior, we are allowing only get and head request, redirect to HTTPS, and these are certain things which you can read and you can understand it, so I am not going from everything. These things you might have to know, like if you get 403 error, then you will have to give response as index.html, and same way for 404. So if anyway you are getting errors, you will be again redirected to the index.html in order to prevent the errors. Now we have certificate. Now what this certificate says, so as I have told you that I want that my custom domain will be serving this CloudFront domain, will be serving this CloudFront distribution. So I will have to make the ACM certificate. ACM is Amazon Certificate Manager. So ACM will make certificate manager, which I will point to the CloudFront distribution. So I will be making ACM certificate here. My domain is star this. So star means any subdomain of this domain name will be allowed, any subdomain. Most recent true, and yeah, this is thing. So this certificate I will then have to pass inside the viewer certificate. So viewer certificate means whatever requests are coming, that request will be coming from this certificate. This certificate I have shown to you. So this is the CloudFront and S3 bucket things. Now I am mostly done with infra things. So let me again clarify you. So we have VPC. Inside VPC we have EKS. Inside EKS we have node group, and inside node group I will be making the K8 as resources using ArgoCD. And we have RDS. RDS is used by the backend services. We will be deploying after some times. And we have for frontend, we are using S3 bucket as a static object storage, and we will be distributing it via CloudFront. So this is about EduConnect infra. Now, as I have told you that our infra repo will be using Jenkins as a CD tool, as a CI/CD tool. So how? Inside it we have Jenkins file. I will going briefly. So we have Terraform in it. These are steps, like any pipeline has certain stages. Which stages you can later see in the CI/CD flow, which I will be showing to you. So these are stages. Stage 1 is a GitHub clone. So we have to first clone the repo, because we want that whatever pushes on this repo I am pushing, so we have to deploy all of them. So first I will clone the GitHub repo, then I will do Terraform init, validate, then plan, and this is the stage which is interesting. This stage means you have to manually approve the plan you have made. So in the pipeline, in console output you can see what sort of plan you have made. So by watching that plan, if you can verify it, then you can approve the approval gate or you can reject it. After approval or rejection, the pipeline will again continue. If you approve, then only Terraform apply will be happening. Otherwise, our CI/CD will directly fail. And again, all things are done, and then we have post. So, like after our CI/CD is done, then in post we have to say that pipeline is completed, which is always. In success, we are saying infra successfully applied. In failure, infra applied to fail. Now let me show you this pipeline. If I go inside this Jenkins, okay. So currently, here I have just copied it 2 times. It is not like that. So just ignore these things. You can see below that maybe I will go to this 11, 10. It is loading so much. Inside pipeline steps, you can see the stages of pipeline and how it runs. Maybe you can see the better pipeline overview. So this is pipeline executed at count 10. So first it will start, then it will check out SCM, then we will do GitHub clone, then init, validate, plan, and after we have manual approval. So if you will approve, it will do Terraform apply, or otherwise it will end. So this type of pipeline we can run for Terraform CI/CD. You can see the seconds it took to run each stage, and after running there is post actions where pipeline ends. So yeah, this is whole thing. Now we are done with infrastructure. So what about the Kubernetes resources? Like we have Kubernetes resources which should be deployed. I will be explaining to you briefly that what I'm saying. So inside EDU connect GitOps, we have charts. Inside chart we have backend chart, and that backend chart consists of templates. These are the necessary things to know that what are these things. So I will start with deployment. There are certain things which you may need to know. You may not need to know, so I will not explain it to you that. So this is deployment. What deployment is deploying? This is deploying that backend image which I have shown to you, that it will be generated by the backend CI. So here I have image, and image will be taken from this values file. This values.yaml file consists repository. So this is repository and this is table. This whole thing I am pasting over here. First repository and then table. And also this backend is running on 8080, so I have to use content port 8080. And one more thing, when we run any backend project, it generally has some environment variables. You may either pass it directly, but it is not the standard way, or not the the production way to do it. We have to do it another way. In Kubernetes we can use external secrets. So external secrets is a way to provide secrets directly through the secrets objects. So here we have external secret is parameter store backend external secret. So these are the secrets taken from AWS parameter store. PS means parameter store, and this is the URL, or this is the name of that parameter. So DB URL will be mapped to this edu connect backend DB URL, which is in the parameter store. Then same way we have secrets, AWS secrets. So this is from AWS secrets manager service. These are the secrets which I am importing from the AWS secret manager. We have DB username, then we have DB password and Gmail password. These three things I am taking from this secrets manager, and then I am passing it inside my containers env. So this is env from secret ref SN backend secret and secret ref PS backend secret. So this is deployment. Now I am also doing horizontal pod auto scaling. So if traffic will increase, our pods will also increase based on traffic, and or it will decrease based on traffic. So I am using CPU utilization. Average utilization is 60. So Kubernetes will try to keep average utilization around 60. Then we have Ingress. This is also necessary thing to know. So Ingress is used to first, I think, services which is in between the ingress and deployment. So service is directly serving the ports which will be generated by your deployment. So we have this selector. So this is label app backend, which is label which I have given to my template. So here is app backend label. Same label I have to pass inside service, and it will map the port 8080 to target port 8080, means this is port's port and this is service port. And then ingress will point to this backend service on port 8080. And now here are some annotations which you need to know. So I have told you that Ingress will be making the ALB inside our AWS, because we are using AWS load balancer Ingress Controller. So whatever ingress I am making, based on these annotations, it will take configs and it will make the ALB. So ALB is internet spacing. So basically I am providing some type of configuration to the ALB which will be made by this ingress. It is internet spacing, it is IP based, it is its health check path is actuator health, then success code is this, and listen ports. So HTTP 80 or HTTP 443, it will ALB will listen on this port and protocols. SSL redirect 443. So we have certificate ARN. This is the same certificate ARN we have generated inside the Terraform. So we have to copy paste it from there, and we have rule. So this is very messy, but we have to follow the syntax it provides. So we have HTTP. So first of all, host. So request must be coming from this host. Later on I will be mapping the CNAME of this ALB to this custom domain. So that's why I have put host as this subdomain. And HTTP any path will be redirecting the request to the backend service on port 8080. So this is whole flow. First we have ingress, then we have service, and then we have deployment. So our first facing request will be ingress, and then request will be forwarded to service, then service will forward request to the ports. Now we have other things which you can then refer. I'll be providing link in the description of this whole project, so you can refer it, but these all sorts of things are important. Now after GitOps, So we have front-end and backend. Now if we will go towards the CI/CD, because when developer pushes the front-end code or backend code, we have to do certain things in order to keep our system active, keep our system correct and consistent. So as we have seen GitOps repo, so I will first tell you what is flow of the backend. So I will go inside the backend. Then for GitHub Actions, you might know that we have to make .github, then workflows. Inside it we can put our YAML files, which are nothing but the CI/CD workflows. These workflows will be ran based on the condition. So here I am providing condition. So push on branches main. So if any push is made on the main branch, we have to run this workflow. We have env. Now if we see from top perspective, then we have this many steps. First step is checkout. So we will first check out to our code. Then I will using JDK 70 because my Spring Boot project is using JDK 70. So I will set up JDK 70. Then I will build and run tests. And now once I have built my project, so I can then use the Sonar Cube scan to check my code quality. So if code quality is below average, then we will be moving forward. Then we will be setting the tag image. So here tag image is set based on this GitOps that 256 has, and that tag I will be using then inside the build. So this is Docker build. Then I will log into the Docker Hub and I will push that image into Docker Hub. After pushing that image into Docker Hub, I will have to update my GitOps repo as well, because we know that ArgoCD will be watching and syncing from GitOps repo only. So whatever latest image we have to update it inside GitOps repo as well. So this is GitOps. This is GitOps job. Inside GitOps job, first we are cloning the repo. Then we are updating the value. Then after update, we are committing and pushing it. So this whole flow is for backend CI/CD. First we are building the Spring Boot app. Then we are building Docker image. We are pushing it to the Docker Hub. Then we are check out to that GitOps repo. We are changing values.yaml there based on our Docker image step, and after it we will commit and push. And after commit and push, our GitOps repo will be consistent to the latest Docker tag image, and ArgoCD will sync the whole cluster based on that latest Docker tag image. So this was all for the backend CI/CD. Now let me show you how things are working on console. So maybe I can go to the backend CI/CD here and open it. So here workflows are inside. Yeah, here I can see the workflows. Okay, so inside actions, workflow will be there. So I have backend CI/CD workflow. How it is run. So first add all, then okay. So I'll pick any of the workflow running. So this was workflow ran for 16th time. First build, test and scan. So inside build, test and scan we have these many steps. So we have seen recently these are the steps inside build, test, scan job. Then we have update GitOps job. This is it. And now after we are applying our tag onto GitOps, the ArgoCD must be syncing it. So where is ArgoCD? ArgoCD is a server which is inside cluster, and I have to provide so this is our ArgoCD UI. Inside it you can see multiple applications. The main application you need to know is Backend app. Inside Backend app we have our deployment, we have our service, we have our ingress, the secrets which I have told you, and pods. So all things are healthy, good to know. And now where can I access it? So I can access it on this URL. So this is the URL. As of now you are seeing white level because there is nothing on the gate mapping of this. But if I show you the health, then you can see it is up. DB status it is also up. So our backend is running. Now we have good news is we have our backend running. Now what about frontend? So how to connect frontend to backend? How to deploy it? We'll see it next. So first let's go to CI part. So inside backend, again we have inside .GitHub workflow. We have one workflow which runs whenever any push happen inside main branch. So first we are checking out, then we are setting up Node because we are using React as a frontend which uses Node as a package manager. Node as a runtime and npm as a package manager. So I'll do npm install, then npm run build. After npm run build, we have certain static files which I will have to push to the S3 bucket, and for that I'll first have to configure our AWS credential in order to access the S3 bucket. So I'll configure it, then I'll upload the builds onto the S3. And after that, one more thing, let's say your CloudFront is now serving some S3 static assets, but you have deployed your new S3 static object on S3. So you now need to invalidate the CloudFront's caching objects because they are now not consistent to what is inside S3. So we have to invalidate the distribution. So that is what I am doing at the last step of our CI flow. Now how this CI flow looks, I will show it to you. If we go inside Connect Frontend, inside Actions, we have deploy React to S3 plus CloudFront workflow. I will pick any of the running instance. So you can see that I have deployed job inside this workflow, and these are the steps it will run. Here you can see the average time it is taking from setup to build to complete the job. So this was about frontend. Now if we see inside the console, so I haven't gone through the console as of now, but I will show it to you how these things look like in console. So first we have our cluster. Inside Elastic Kubernetes cluster we have EDU cluster. So this cluster is having some resources, some compute. So as of now I am having 4 nodes inside my this EDU cluster. All 4 are T3s node. One node group is there, ECAS node group, which I have shown to you in Terraform part. These are the resources. And if I see load balancer, also I have told you that Ingress will create load balancer, and one Ingress I have created for the backend part. Like if I want to serve my backend service, then I have made Ingress there. So that Ingress is making this K-test backend ALB. So this is the domain name of the ALB, which I have used as CNAME for my this subdomain, edu backend. Okay. And now S3 bucket. So I have multiple S3 buckets, but maybe I will use this edu connect remote, and that S3 bucket is front, or it is distributed by this distribution. So if I go inside this distribution, so alternate domain name, as I have told you that I want that my custom domain name will serve the content. So I will have to provide the alternate domain name. I will have to provide the certificate of that alternate domain, origins. So we have S3 as origin, static S3 as origin. Now if I will go to my custom domain, this custom domain, it must serve the static files. So if I go inside it, yeah, it is serving the static files from S3. First point of access is a CloudFront, then CloudFront will go to the S3. S3 internally will use the backend ALB to run all the APIs. So this is my website. If I go inside the network tab, this is the network. So this is my website. You can see I can do all the things. I can message, I can queue connect. If I want to make one question, I will take some topics, I'll post my question. I successfully posted question. If I refresh, it will still persist because we are using RDS database. RDS database is our third tier for this website. Now we have successfully made our front-end and back-end connecting together. We have made our custom domains serving the content. Now what about monitoring? Because we know that we have first everything is met, but we have to monitor it every day in order to see how good performance the website is serving. Is there network spike? Is there request spikes which are causing performance or everything? So we have to see or monitor our backend all over the time. For that we are using Prometheus and Grafana. Maybe I will again go to this architecture, and inside it you can see that inside Kubernetes we are having Prometheus. Maybe some of you not know that Prometheus is used for metrics fetching or metrics collection, and that metrics will then be dashboard by the Grafana. So Grafana will show the dashboard of the metrics stored inside Prometheus. So I have this ALB Ingress Controller, and Prometheus will collect the metrics from this backend, and that metrics will be used to provide dashboards in the Grafana. So Grafana is used for dashboards. First I will show you Prometheus. So this is dashboard of Prometheus. Now I am fetching the, you can say, metrics from the target is our backend. So this is the same backend. I am fetching the metrics. If you go to that, you can see that here are key values. So this is the metric name and this is metrics value. So there are certain metrics which Prometheus fetches after some time. Maybe it is manageable 10 or 15 seconds. It will fetch the metrics from that backend server. It will store it inside it. Now Grafana will be used to make dashboards. We have certain dashboards. We have this Springboard 2.0 statistics dashboard. Now this dashboard is using that Prometheus as a source of metrics. So via that metrics, we can see these many things in our dashboard. So uptime, it is up from 13.5 hours. Heap memory used is 39%. Non-heap memory used is 11%. Then we have other things as well. Classes unloaded, so it reduces to 1.13 over some time. In same way, we have another dashboard for JVM. So here we can see JVM dashboard. Here also JVM heap, JVM non-heap, these things are there. So now this was about monitoring, and if we go inside the architecture part, then we have successfully covered almost all things. Okay, some things are missing, some things I haven't explained to you, maybe inside the Kubernetes manifest or Terraform, but they are easy to understand. You can go to my GitHub repo. I will be providing link inside description. You can check it out. You can refer to it, and it is easy to explain because major things which were required to know I have explained to you. So you have very good knowledge of my project. You have very good knowledge of this whole architecture. I hope that by following my readme.md, you will be also able to deploy this project, or you will be able to learn from it. So yeah, I have, let me see the files. I have completed all the things. Yes. Also, there is DevOps notes. These are the notes I have pushed, which I have made in while making the project, and these are specifications. So better idea of my project you can take also from the specifications file. If I open preview, so here all the things I have defined about my project. So yes, this is my project. You can comment it down, like what if you have some queries or questions related to this project, you can comment it, or otherwise if you found it helpful, if you got some values from it, please like it, because YouTube will show this project to other people. It will help others as well. And that's it. Thank you guys.